Hello and welcome to another episode of Study Session for AP Physics 1. In today's video, we will be covering uniform circular motion, Newton's law of gravitation, and rotational motion. Okay, so let's first get into our very first practice problem. So the first problem says 60 centimeters of rope. So I'm just going to write 60 centimeters up as 0.6 meters just to save time, I guess, converting. It's tied to the handle of a bucket, which is whirled around in a vertical circle. So I'm going to draw a vertical circle. I'm just going to write vert, just so that I remember it's vertical. And it says the mass is 3 kilograms. Okay. So it wants to know, so it says at the lowest point in the path, the tension of the rope is 50 newtons. Okay, so at this lowest point, the tension in this rope, so T equals 50 newtons. It wants to know, what is the speed of the bucket? Okay, so your centrifugal force equals mv squared over r, right? And your centrifugal force is equal to your net force pulling you towards the center of the circle. So if we draw a free body diagram for this object, we've got our ft, but we've also got the fg, the gravitational force pointing down. So to solve for our fc, we have to find the net force pulling towards the center of the circle, which will be equal to fc equals ft minus fg equals 50 minus, and then, so we're going to use 10, I'm just going to use 10 for gravity because I don't feel like pulling out a calculator using 9.8. Plus, I'm pretty sure the problem that, the solution to this problem is assuming you use 10 anyway. So if we do 50 minus 10 times 3, because that's g times m, it would be 30 minus 30. That equals 20 newtons. Ooh, that was a really bad end. 20 newtons, okay. So if we plug that in here, we've got 20 newtons equals the mass, which is 3 kilograms, times the velocity squared, and all that is divided by 6 meters, because that's the radius, because that's the length of the rope, like it would be also 6 meters up there. But I'm going to write that as 6 over 10, just so that I don't have to use a calculator. So if we quickly multiply across 20 times 6 over 10, that would be 2 times 6, which is 12. So that equals 12, and then we can cancel that out. And then 12, if we divide by 3, equals 4. So that cancels out. So 4 equals v squared. So the velocity equals 2 meters per second, because the square root of 4 is 2. Okay. Now, I think the next problem... Okay, so the next question also involves the same problem. So I will keep the values still on here. Okay, so it's still a vertical circle. So it wants to know, what is the critical speed below which the rope would become slack when the bucket reaches the highest point in the circle? So the rope becomes slack whenever the only force that's acting on it is gravity. So that's Fg. There's no tensional force pulling it in. So Fg, in this case, would equal Fc equals mv squared over r. And we know that Fg, so Fg equals mg, so I can cancel out those m's actually. I can get g times r, the square root of that equals v. So if we do the square root of 6 over 10 times r, that is r, sorry. Let me go ahead and just rewrite that so it's consistent. If we do 10 times 6 over 10 equals v, that means v equals the square root of 6. And this one you would kind of need a calculator to do this, but I know it should be between 2 and 3 because the square root of 4 is 2 and the square root of 9 is 3. So in this case, there's only one answer choice that's between them. I'm just doing it without a calculator. I can pull out a calculator real quick and just verify, but it should be 2.4 meters per second. But if I quickly do this in a calculator, the square root of 6 is equal to 2.44949. So yes, that is correct. Technically, it should actually round up to actually, no, it shouldn't round up. So never mind. 2.4 meters per second. So that's how you solve that one. On to the next problem. Let me just see real quick if it uses the same. No, okay, it's a different question. So I can erase all this. Okay. It says an object moves at a constant speed, so constant speed in a circular path of radius r, so radius equals, looked like radius equals v, radius equals r, at a rate of 1 revolution per second, so 1 rev per sec. what is its acceleration? So we want to know the acceleration. Okay, so we know that our acceleration, our centrifugal acceleration equals v squared over r. So, and we know that this is one revolution. So we basically have to solve for our v. Basically, is what we have. We have to take one revolution per second and solve for the velocity. So one revolution per second essentially means that you're going to go 2 pi r, which is like your length, because that's one revolution per second. And if we think about it, velocity, v, equals displacement over time. So our displacement is actually 2 pi r. That is our displacement. And it's per second, like velocities would always be in per second. So like let's say this would be 5 revolutions per second. We would have to multiply this by 5. Or if it was 1 revolution per 5 seconds, we would have to divide by 5. So in this case, it's 2 pi r per second. So that's our velocity because that's distance over time. It's covering 2 pi r per 1 unit of time. So if we plug this into the formula, we get 2 pi r quantity squared over r equals acceleration. So that would break down into 4 pi squared r squared over r. This r will cancel out with a squared, so we should just get 4 pi squared r, which is the correct answer. Okay. Now on to this next problem. Let me actually go get a gravitational, something to do with gravity. So let's do this. Okay. So this question says the distance between 2 point particles is doubled. Then the gravitational force between them. So we know that Fg equals m1, m2 multiplied by big G over r squared, right? So we've got A to B, right? Okay, so let's call this object A, let's call this B, and we'll just say that this distance is a distance d. We know that the gravitational force equals ma, so ma times mb times big G over d squared. But if we double this length, right, and we got A, and we got B, A, B, but this length is 2d, not 2b, 2d. Okay, then our Fg would equal ma times mb times g over 2d squared. And since if we square that quantity, we would get d squared, and then this would actually become 4, so 4d squared. So if we compare these, we can pull out a 1/4 here, and then we would have a direct substitution in for this. So we know that if the distance is doubled, the gravitational force is a 4th. So it decreases by a factor of 4. Okay. So let's go ahead and do another universal law of gravitation one. Let's try, I'm just trying to see. Okay, so a moon of mass m, so mass m, orbits a planet of mass 100 m. Let the strength of the gravitational force exerted by the planet on the moon be essentially, I can't pronounce that word, so I'm just going to say represented by F1. Let the strength of the gravitational force exerted by the moon on the planet be F2. Which of the following is true? So this is testing Newton's laws. So if you recall, one of Newton's laws says for every action there's an equal and opposite reaction. So in a closed system, like if you push, so F1 has to equal F2, because if you think about it, let's say you've got this box, right? And you push against this box. Well, that box is going to push equally back at you with the same amount of force. So if you recall back to Newton's laws, every action requires an equal and opposite reaction. So if the moon and if the moon is the only thing acting on the planet, and the planet is only the gravitational force of the planet is the only one acting on the moon, you would see that the two forces are the same. Plus, you can think about it logically. If Fg equals m1 m2 g over r squared. I don't know why I called that big R. I just did. It accounts for both masses. So whether you're doing it on one mass or the other, you're still going to get the same force, right? Because you have to substitute in both masses. So you can think about it that way as well, just based off of the pure formulaic approach. On to the next question. Let me see. Just trying to find a good one. You know what? I'll go with this one. So a moon, and this will be the last problem for this section. A moon of Jupiter has a nearly circular orbit of radius big R, so radius big R. And it has an orbit period of t. Which of the following expressions gives the mass of Jupiter? So if we recall, so it's got a radius of r, correct? Our time period, if we recall, the time period equals 2 pi over your angular speed. If you remember, your angular speed equals v over r. So time period, actually, sorry, this was a wrong approach because this, in fact, did not, actually, no, this is valid, okay. So basically, what we're going to need to do is solve for our speed. We're gonna need to solve for our velocity, because if we can solve for our velocity, we know that Fc equals mv squared over r. But if we remember our gravitational force equation, Fg equals m1 m2 g over r squared. So we can do some formula substitution. So let me just quickly erase this because I'm going to run out of room if I do not. And I will write smaller, so then we can do this. Okay. So time period equals 2 pi, and then I'm going to go ahead and do this because I just said W equals V over R, and that's just rearranging the formula. So we get that V equals 2 pi R over T, okay? So FC equals the mass of the moon times mass of Jupiter times big G over R squared, okay? So mass of the moon times the mass of Jupiter times G over big R squared equals the mass of the moon times 2 pi R over T squared over big R. So this R, if you multiply it across, it will cancel out with this squared. Mass moon cancels out on each side. So we get that the mass of Jupiter will equal mass of Jupiter equals 2 pi, and this should be 2 pi big R. So if I'm going to go ahead and square all this out, I would get 4 pi squared, and then I'm going to have to multiply across by that r, so it's going to be r cubed over t squared times g. So that's the answer. So the mass of Jupiter is equal to that. So that was some nice algebraic approach. For a second there, I was like, wait, this formula doesn't account for mass, but I realized that it's just an intermediate step. You just need to solve for velocity. So hopefully you guys enjoyed this video. If you have any other questions, be sure to visit my website, studysession.org, and ask on there. Hopefully this helped, and I'm out.